Hope you guys can see my screen very well. Hello, good afternoon, good evening, good morning, depending upon where you are joining from. Um, this session is regarding the AI agents in the cloud, automating enterprises workflows with AI. That's the session all about. And as a part of this session, we are going to discuss about how do we enable these capabilities in a large scale enterprises. So let's get started. Before I start, let me introduce myself. I am Rajneesh Kaushikk. It's a great pleasure to be here today with all of you, all AI professionals. I'm Rajneesh Kaushikk, and if I have to describe myself in one sentence, I would be someone who will be very much obsessed with turning these ambitious AI ideas into modern governed real world application, which works really in the production environment. Over the last 2 decades, I worn many hats, from debugging the early .NET applications to, building modern AI landscape for Fortune 500 companies. And now I lead Databricks practice for Virtusa. And yes, I proudly carry two tags, Databricks MVP, Microsoft MVP, and Databricks Champion as well. But beyond these labels, what really drives me to today is that we are in an era where all AI systems are evolving from the standard chatbots to the autonomous agents, right? That can make decisions for you, um, take actions on your behalf, improve themselves as and when they go. And then that is what today's topic is all about. How can we architect these future with the tools which you already have, with you today? And so let's dive together in this agentic AI. And it's no more a science. No more a science fiction, but actually this is the future. And this could be your next deployment. So let's get started, guys. And by the way, before we start, just wanted to also tell you that here is my website, rajneeshkaushik.com, and here is my YouTube channel where I usually, share my knowledge. So yeah, if you want to subscribe to my YouTube channel and website, here it is. So let's get started, understand what is the session all about. First of all, we are going to learn what are AI agents, how do multi-agent system works together, what are the core architecture concept of Azure AI agents, the power duo of Azure OpenAI and the Azure AI Foundry agents. We will then delve into the use cases of AI agents and then what are the best practices to build these agents. And finally, we will jump to a quick demo where I'm going to show you these things in action. And then I will also let you, I will leave this session with the how do you build your first agent when you go back. So let's get started. So what are AI agents, right? AI agents are autonomous software entities, which is designed to operate independently during executing the task without human interventions. So these are called AI agents. Just give me 1 second. So can we, if you talk about this AI agentic system, right? Agents are something like a small robot who works independently, right? Who execute the task on your behalf without you intervening or minimal intervention from the user, right? They not just execute the task, they also have a human-like decision capabilities. They can take the decisions, right? They can interact with the cloud services. They can interact with the different multi-systems together. And that is what the whole concept is, the AI agents, right? It's very popular topic nowadays across the industry. So when you talk about single agent, okay, but when we talk about multi-agents, right? Multi-agent is very, very interesting topic, guys. how multi-agent works, right? If we talk about one single robot, it is okay. But when you talk about multiple robots or multiple agents, they talk to each other as if we are human being talk to each other, work together, and based on that, they work as a cohesive team. So this is we are going to learn how they work together. First of all these agents provide a specific set of role for which they are very much specialized in doing their job. Let's take an example, like if you're talking about a travel agent, he's very specialized in booking a travel. When you're talking about an accounting agent, he's very specialized in doing the accounting related stuff because he is trained to do that. He's certified to do that. Same way, agents are having a very specialized role for which they are very much capable to do it. They have effective collaboration happening, which means that all the agents can talk to each other, find out the messages from each other, work together as a team. And when we talk about interaction between them, for example, if inventory agent find the inventory and then sales agent find a sales issue, then they can talk to each other and find out whether if inventory is low, can we order that inventory with the order agent. So these are the agentic AI which effectively collaborate together and work, and the whole process happens seamlessly in such a way that performance is optimized by when you assign this task to a suitable agent, and the agents are very specialized, then this whole performance go to the next level. Now, before we get deeper into it, let's understand what is this core architecture concepts of Azure AI agents, and so that it will help you to build these agents. So first and foremost, these agents have a couple of components. Like first of it is memory storage. Memory components in the Azure AI is very important because it stores the past interaction happening with you, and it also helps them to take a further decision based on the past conversations. Then there is a specific concept called planning actions. Whenever you assign a task to agent, there is a planning component inside it which plans the overall flow of the task. Because the major difference between the standard chatbot and agent is agent can give you decisions based on the planning which it has performed. And this can be very dynamic planning depending upon the different scenarios, right? So in the standard chatbot, it is a standard flow, the very same flow. It does not change if the condition changes. But in case of autonomous agents, the communication or the whole flow changes based on the decision making capability. If decision A is taken, then the flow will be different. If decision B is taken, then the flow will be completely different. So that is the difference in the which it makes with the help of the planning component. Then based on the planning component, it execute a certain plan, right? For example, if I have to travel from point A to point B, and then there are some conditions due to which the roads are blocked, then I will take a different road. So that is a planning, and that is a new execution plan instead of the first execution plan. So that is the difference between when you do the static versus dynamic. So this is execution plan which is very dynamic based on the planning action taken. And when it does this execution, it does not do it on its own. It actually uses some external tools. For example, in case of a travel agent, it can call Bing, it can call Waze, it can call different components so that it can get help from these tools, external tools, to execute the task for me, right? So that is the beauty of these components. Now, very important component in this whole scenario is called tool-based interactions. So whenever a agent calls the external API or an internal function, this interaction happens in a dynamic fashion depending upon the requirement. For example, if a agent try to book a hotel or try to book a itinerary for you, and that time itinerary trying to find out that okay, now the flight is going to go via the specific area, where you don't want to go because of the war-like situation, then it will change the whole action plan, right? And when it does it, it calls the different tools, and those tools are at its disposal, where it get the outcome response from these tools and changes the whole overall plan. And predominantly, these tools mostly are, internet-based or RESTful API-based tools, or your cloud-based services. Could be any number of tools. As far as those tools, you are able to call those tools. These agents work not in a solo mode, they work in a shared context, shared state, which means that agent A knows what agent B is doing, but what is the role of agent B versus what is the role of agent A. If a specific scenario comes where agent A is not able to work, then it knows that which agent will be suitable to make it happen, and then the context is shared with that new the different agent, and that agent execute the task. So there is some context switching. There is a shared state where they can access the information from each other in a shared memory, shared state. And then they make a coherent decision making where all the decisions are made in such a way that they are utilizing each other, helping each other to make it happen. The way of human works today, right? The most important part of this whole scenario is predominantly the importance of security, because all these tools which is getting access to your environment or data, it is very very important that you make sure that you have a proper security done, right? There is and these tools are pretty much available in Azure AI Studio tools. And as you know, Microsoft Azure is one of the most secure environment in terms of when it comes to the governance and security and identity control. So ideally, all this Microsoft ecosystem like Azure AD, Intra ID, and then all the identity related specific controls, RBAC controls, all these things works for you, right? So the whole Azure AI Studio and the security and governance provided by it is already with you. It makes this whole agentic communication very, very secure, safe, and foolproof. Now, so far you understood that, okay, these are agents, how this agent works together. But now let's think about how do I develop it? So if you want to really develop it, there are two components you should be knowing it very well. The first and foremost is Azure OpenAI, and the second one is a Foundry agents. So let's understand what is this all about. The first and foremost, Azure OpenAI service, this is actually provides a enterprise grade LLM capabilities where it provides you all that OpenAI capability, which is a very powerful model with the different kind of versions around it, right? And you can pick and choose these versions. And Azure OpenAI is deployed in the Azure ecosystem, so it is not the same OpenAI which you use from outside, like ChatGPT. It is more secure. It has some grounding done already by the Microsoft, right? And it has inherent capability to work on the natural language understanding so that it can answer all your questions. Now comes the next part, Azure SDK. Azure provided a service delivery kit which helps you to develop these agents. It also helps you to do the orchestration of multiple agents under one umbrella. And then it also has a very easy framework where you can develop the code in a easy Python libraries so that you can assign the task to the agent depending upon the what kind of role the agent is taking. And then if you can also tune this performance and deploy it in the Azure environment. So this is a beauty of the Azure SDK, and it is evolving as we speak, right? And if you talk about the Azure um, AI agent service, it is in preview. So there are a couple of new capabilities they are building as we speak. But yes, it is pretty well designed, right? And I'm going to show you the demo for this. Yeah, so now after we do this, then the next most important part of agent development is prompt engineering and parallel reasoning. Prompt engineering, as you know, prompts are a core of all the agentic AI, right? or any agent-based system or any generative AI-based system. It is very important to have a proper prompt engineering done so that you can get a desired result. And when in the case of a multi-agent system, there are parallel reasoning happening together with multiple agents, and then there is a comprehensive responses coming, and it is all depending upon how well your prompt works. So prompt engineering is a central to it and very key theme for this particular capability. Now, when you call any external tool, right, you need to call these tools with the help of REST API. Because if you talk about the Bing or you talk about any other travel agent service like Expedia or any other tool, you need to call these services with the help of REST API. And for all the very specific custom scenarios, you need to have an integration for REST API. And that is where it helps you to extend the capability of the tool. Now, we understood how this whole ecosystem works, how the whole Azure AI agent works, what are the different capabilities, what are the different tools we have in this today. But let's understand what are the real world use cases of AI agents, right? Because without real world use cases, it may not make any sense for you to go ahead and develop or deliver anything on it. So first and foremost, very, very important one, incidents report automation. So suppose there is incidents happen, right? And then you want to make sure that, immediately when the incident happen, there is a response triggered for those incidents. And then that will help you to reduce the downtime of the system because request and response is already, done by the automation agent. And at the end of the day, your efficiency is improved, your downtime is reduced, you are having more, happy customers. So this is one of the critical use case, real world use case. Then another one is a threat detection and resolution. As you know that these threats or incidents, they can happen anytime in the middle of the night when you're sleeping. So there we need a system which can work when these incidents or threats emerges and immediately identify the vulnerability in the system and then proactively do the corrective measure or put a patch towards it so that all these threats can be addressed there and then. So it is not just identifying it, but also resolving it with the help of dynamic nature of agent. Then another one is compliance report agents. So you in the regulatory environment, right? Regulatory environments are very time sensitive, time critical. And whenever any compliance issue happens, we cannot afford to wait till end, right? We need to immediately make sure that we are compliant with the regulation. And in order to achieve that, we need to make sure that those compliance criteria are met, those compliance activities are performed. And in order to perform that, if you use the agentic AI or a multi-agent system, they can actually execute on your behalf based on the compliance requirement and take that appropriate action. Then another one is a cost optimizing agent that can help you to optimize your cloud cost and make it a efficient cloud operations, wherein it can help you to identify what are the potential costs coming from, why it is coming from, can we reduce it, and take those remediation action on the top of it so that your cost is under control and your customer satisfaction is at the top. So that is the one benefit of cost optimization agent because this cloud environment today, right? You come to know the cost after 1 month, and by the time the cost is coming, it's already late. You cannot change anything because you already incurred that VM which was running for the whole 10 days without you knowing it, already billed to your account. You cannot now do anything except to just pay the bill. If these cost optimization agents are there, they can go ahead, find out what are the cost optimization opportunities, immediately perform those cost optimization. For example, if VM is running but nobody is using it, shut down. If VM is running and somebody is using it, and then you see that there are VM does not even need this kind of CPU and memory, so you can reduce that CPU and memory So like these kind of capabilities are there where you can use AI agents. Now let's dwell deeper on what are the different design best practices, right? Because if you have to design these agents, you need to know what are the best practices to design these agents. So let's dwell deeper. Whenever you create any AI agent, make sure that your design is in modular. It is you are developing a specialized agents. You are making sure that they are very highly efficient and very effective in performing your operations. Why? Because if you have not have a specialized agent, they won't be able to perform well for those scenarios. So that is why it is important to have a special set of agents which are very specialized. They have tool at their disposal to execute those specialized tasks. They are very highly efficient. When they do perform their operations, they can do it very fast, accurately, in a performant way. And that is where it comes very important to have a clear rules and modular agents. And modular means also that agent perform one task at a time, does not perform 10 tasks, different tasks, and it does not know when it has to execute a particular task. So it should be very clearly specialized task performed by one agent at a time, and then if it cannot perform that agent, it can hand it over to the next agent. Sharing memory and context with agent state. Another very important design practice is share the memory and context with the agent state. So whenever these agents work together in a collaborative way, they need to share their memory, their messages together with each other. They should also have a data access. So if one agent is using one data set, another agent should also know that data set so that they can. It is something like when we say in our Teams environment, we are on the same page. So these agents should also be in the same page. Otherwise, they will do something completely different and they are not going to synchronize with each other. So synchronization can only happen if you have a unified data, right? And then we should also make sure that the overall performance the outcome which they are doing is as per your requirement. So these, if you follow these practices, your agents will improve the goal outcome. Now another aspect of it is how do we, when you deploy these agents, so first of all developing is one part, but when you deploy these agents, right, you need to make sure that your agents are performing well, they are not degrading their performance. They are understanding. It should not happen that, okay, today I deploy my agent working 100% correct. After 2 months, when the new condition comes into the market, right? For example, stock, suppose I'm doing a stock trading and now my agent is working fine today, but after 2 months from now, my agent stops the response time is changed. The decision making is deteriorated. It is not doing the correct decision making. So that is because of all this, what will happen? Your outcome will be deteriorate. And in order to achieve that objective of making it a perfect agent, you need to monitor them day in and day out, and also know how this agent is performing and what are the outcome it is performing, whether it is performing correct, it is not hallucinating. It is also there is a continuous improvement opportunities coming out of it. So do the continuous improvement. So these are the capabilities you need to, and that is only possible when you have a monitoring them and then logging those decisions. Another important part is that when you deploy these agents, there can be chances that there could be hallucination happening, right? Because AI does hallucination, right? OpenAI and all these models, they hallucinate. So in order to do that, first and foremost, you need to have a clear guidelines so that it can, or clear prompt so that you can minimize the risk of hallucination, and it will help you to build a strong trustworthy AI computing, AI agents. And then you should also make sure that there is a operational limit, because sometimes what happen, if you keep asking similar kind of question, it can go on and on and on. And if you say that, okay, my question answer limit is 5 questions or 10 questions, good enough. But if you don't set a limit, it keep on asking the same thing and going in a loop. And then at the end of the day, you will see that there are thousands of tokens wasted in that. So there should be a loop avoidance, which means that stopping the loop. And then in order to stop the loop, you need to also have a infinite preventing the infinite loop. Sometimes the agents go into the infinite question answer. The same answer question is coming, and based on that, it is giving the same answer. And based on that answer, another agent is giving the different same answer. Then again, it is passing the context to the first agent, again giving the same answer. So it goes into the infinite loop. So you need to break that loop by setting the limits of that loop. Okay, it is something like a for loop in C, C++ or any other language. If you put an infinite condition in the for loop, it will keep on executing it. Another important part is using your Azure AI Studio for the deployment purpose. For example, you have Azure AI Studio, and this Azure AI Studio, if you use, it is a pretty much nice interface in terms of the deployment capabilities. It deploy all the resources in the cloud environment. It helps you to see how the whole environment is coming up, and then it's pretty integrated interface, right? So if you use this, it is easy to deploy and execute and run. And there is a very nice interface for talking about playground. You can play with the agent before you deploy it. So now let's understand. Because now you know what are the best practices, right? How do I design my agent? How do I make it more? How do I make it, you know, preventing the loop and avoid the hallucination? But why these enterprise need this AI agent, especially in the enterprise scenario? And we saw a couple of use cases, but let's see one of the scenario, and this is going to resonate very well with you, because if this scenario, like for example, um, and I'm giving you very specific scenario because we are going to implement this scenario in our demo. So in this scenario, I'm going to show you that whenever a new alert comes from the VM, for example, in your Azure environment or any other environment, there are some, alerts are coming by the VM. Alerts are, going into the monitoring system. And then whenever that alert comes, right, you need to act on this. There might be a 24/7 ticket response system where people might be working on day in and day out, and they want to do the investigation and see the investigation, and they want to resolve those investigations. So this kind of manual alerting and investigation which you do because somebody need to be uh, awake for the whole night, and then log that alert and then take action. It's very slow process, right? It is not scalable for large environments, for large set of customers. And when by the time you do the investigation, it is very late. Your whole environment is crashed, and that by the time you understand, for example, if you got an alert at 2 o'clock for your hard disk full, and then by the time you take action, the whole system already crashed. The production environment is gone, and by the time you take action, it's too late. So that is why it's very important to take action. And there is in the cloud of ops, if you talk about where they do the operations for the cloud, these are mostly reactive. That means if something happens, I am going to take action instead of a very proactive approach. Proactive means before any action could happen, I will take a precautionary action so that this event will not happen. Right. For example, in a air travel, right? You take a precautionary action by making sure that your aircraft is serviced, all the maintenance is over before you hit the airport. So that is where the whole proactive approach is. But generally in the cloud ops team, it is mostly reactive, and we need to have a proactive approach. And another challenge we have is that um, you have to keep doing the triaging of the issues. You need to put a remediation plan, do the remediation. And at some point of time, I have seen in my career that when I used to work in a large infrastructure company, the people are very drained. They are very tired because day in day out, sometimes some incidents can run for severity A incident can run for a couple of days. So it's very draining, resource draining, very painful, very difficult to triage those issues. And the whole strategy should be, automating the mundane task so that you can direct your effort towards the more strategic initiatives where your team can perform and then you can achieve your organizational objective. So that is why it is important to have a very, these repetitive tasks and triaging and remediation should be automated. And obviously you cannot automate all the tasks, but at least some of them, right? And if you even automate 70-60% tasks, then still you are able to save that much bandwidth from your resources. So with this problem, we need a proactive system that can sense, that can decide what to do on the dynamic nature of the problem and act in a real-time situation instead of waiting for somebody to come and then do it. So this kind of real-time sensing and automated action and informed decision making is only possible with the help of an AI agents. So now let's see a live agent demo, a live demo for agentic AI. And as a part of that, I'm going to show you, AI agent, which I am going to show you very quickly. One second, just sharing my screen. Okay, so first and foremost, I'm going to show you a. Let me share my screen again. Okay, so if you see this whole agent playground, which is a part of your AI Foundry, and in this, if you see virtual machine, so now when I'm asking a question, for example, let me ask a couple of questions here to showcase this capability. And this is the feature of the Azure AI agent playground, right? I'm going to ask some questions to the agent. I'm asking a question. A virtual machine is reporting high CPU usage. Can you check? And can you check the incident detail from the system? That is the question I asked. And immediately it found that latest incident shows a disk issue on VM named this. The CPU usage is reported to be 86%, which is below the 90% threshold for taking direct action based on CPU usage. However, since the issue type is disk, I will query the knowledge base for guidance on resolving this issue. And after that, let me check the knowledge base. So now this is one agent which is finding the monitoring the events for all the VMs. And when it goes through that event, it found that there is a issue with this event, this particular VM. And then it calls the knowledge sharing agent. The knowledge agent recommend that clearing the temporary and log file is a resolution for high disk users on a VM. And would you like me to proceed with this action? And then after, if I say yes, it will proceed with that action. Okay. There is another scenario which I want to show you here. So now let me ask another question that based on the incident data, can you analyze what might be causing the high CPU usage? Okay. So now based on that, it goes back to the particular machine and it says that the incident data indicate that while high CPU usage is present in the main issue type and it is identified as a disk high CPU usage in the context, and secondary effect of the disk issue is there are possible causes of this issue: disk read write bottleneck, log or temporary file or overload, disk fragmentation or corruption, or application writing excessively on the disk. So these are the recommendation it is giving you based on the knowledge base, right? Another part, let's see. Can you search the knowledge base and let me ask this question. Can you search the knowledge base to find any documented fixes for this type of issue? So now it is searching the knowledge base and finding it out what could be the problems. So yes, so it found that the knowledge base recommends clearing temporary log files and resolution for high CPU and disk uses on this VM. And would you like me to perform this? When I say yes, so it will perform that, right? And same way, if you ask that, can you take a appropriate action, remediation action to fix the high CPU uses? And I'm telling it to take a remediation action on the top of it. So what it is doing is it is saying that I successfully performed the action to clear temporary login file because it found that there is a temporary login file is a resolution. So now I am asking it to perform it, and then it has already completed it, and then it is saying that this issue is resolved, and now it is monitoring the system for further anomalies, or it can let you monitor it. So instead of you doing it, it is done automatically by the agent. Now let's call another capability where it is asking that, okay, summarize all that actions which you have taken and to resolve this issue. So I can log it into the cloud ops report. So here the incident for VM is this: reported high CPU usage alongside a disk issue. After analyzing the situation and querying the knowledge base, I recommends resolution was to clear temporary log file. The corrective action taken was clearing temporary log file as a part of the process. And then this action was successfully completed and the issue is expected to be resolved. Do you need more assistance? So see how beautifully it is going ahead, resolving your issues, going one step at a time, reporting you the whole scenario, finding the knowledge base. Actually, another issue you will find that if suppose you talk about a human related processes, right, where human beings are doing some work. And if you found some new knowledge based on your experience, that knowledge is with only one person. It is not shared with other people. But in case of agentic AI, it is documenting that knowledge in a knowledge base, using that knowledge base to execute those tasks. So knowledge is keep on accumulating and it is becoming more and more intelligent. And it is based on all these things, it is finding it out how it worked on that particular step and how it resolved that issue. So this is a beauty of agentic AI, right? It helps you to document all those steps, finding it out what could be the challenges in the current environment, finding out which VM is a problem. Now, if I ask you same question, which VM was the issue? Now this time it may find some other VM, right? So here it might be finding some other VM, right? Like for example, VM name is now different, production VM, right? And it is in East US. Before that, it was Central US VM. So it is working on it, and then it is finding out the knowledge base to find it out what need to be done, and then keep on working, and then making sure that everything is taken care, right? So that is the beauty of the whole, agentic AI. Now you might be thinking, how did I develop it? Okay, so let me show you how did I develop the whole environment. So this is a agent playground. Okay, and then here, if you come to agents preview, in this I have created a cloud incident agent, and I have created multiple tools to it. One is a take action tool. So this take action tool is a custom tool. And how do you create a custom tool? Very easy. Let me show you how do you create a custom tool. You come here in the action pane, and in the action pane you add, and then there is a open API 3.0 specified tool. When you click that tool, you provide a name of the tool and click next, provide the specification of the tool, and next and next and next. So you create a tool like that. So now let me show you what are my tool doing. So in this case, my tool name is, there are three tools. First of all, first tool is get incidents tool. Second is search the knowledge base article. third is take the action. So let me take you to all these three tools together. First, let's go to the get incidents tool. So this tool, it is running on this URL with the ngrok tunnel, and then it is finding out the, this is the path of the incident, like a REST API call. And then there are these properties where it is, expecting. So, and then we are creating a tool. Same way, we have created another tool called Search KB. Search KB tool does exactly same thing. It has a OpenAPI specification here. OpenAPI specification is nothing but a API specification which helps your agent to know how do it call the API. If it does not know how to call the API, it will not be able to call it. So in this case, it provides that, okay, this is API, how to call it, what are the parameters to call it, what are the responses, 200 is okay response, right? What are the description, what are the application JSON information. And last is your take action. Take action, again, similar kind of thing. We have to take action, and action to take is restart, scale the environment, or it could be anything else. So for the sake of simplicity, I just took two actions, but it could be multiple actions. Okay. Now you can make this tool very, very complex. Like, for example, you can make this tool to do execute many different tasks. It can connect to the remotely to a VM, collect the log from the Azure monitor, collect or analyze those logs, find out the problems in the log, and then take action. So those could be options. You can also connect this to Search KB by logging those information in the knowledge bases, connect that tool to the knowledge base, find out the remediation step, and then execute it. And likewise, you can do it. And then part of it is another approach which I have taken. This is my prompt design. So I'm telling it that you are a cloud ops assistant that helps detect the issues and take corrective action. And this is a process. Use the get incident section to detect the latest alert. So I showed you just now get incident. The response will include this name. This is the response time, how it is going to go. And based on the issue type, apply the following logic. So now, first, if issue type is CPU and it is greater than 90%, then take action to restart the VM. If issue is this, then take. So all these things can also be, taken care by the knowledge base, right? It could be anything. And then it is also telling that provide the final summary. So you can provide a summary. And then it also saying that if a tool fails or data is incomplete, ask for clarification or provide the fallback guidance. So you are providing all these details to it, right? Now you might be thinking, how did I deploy my API, right, or tools? So in this case, I'm actually deploying my tool here. I created a Flask application, and first of all, I'm showing you this. This is my JSON, which I just showed you, right? And now let me show you my Flask application quickly. So this is my Flask application, and this is where I have deployed these three actions. Like first is your get instance action. Okay. Second is your take action, and third is your search KB action. So these are the actions. And just to make it simplified, I have just mock it, but you can make it very, very advanced one, right? And then in order for my tool to call this, I'm using a ngrok. Ngrok is a tunneling system where the application can call to the ngrok system, and then it can service you from the local host. So if I talk to you about the local host, this is my local host. This is how the whole REST API call happens, and then how it is coming up here. Okay. So with this, you saw that how I created Azure AI agent with the three tools. Then these tools calling the Flask API. Flask API is deployed in my local VM, my local laptop, and that call is happening with the help of ngrok. tunnel from the cloud, and that is how the whole process works. Okay, so now let's change the gears, and I'm going to show you, the next step. Okay. Okay. So now you saw the live demo. So this is what we have discussed about the live demo. The first and foremost, we saw that how it detect the high CPU uses and fetching the logs, how it diagnose the CPU problems, it automate the log fetching, it diagnose and troubleshoot, and then it is also suggesting and executing the fixes on your behalf and executing the solutions, identifying the issues, and we have done the data-driven decision making with the help of such KBs, operationalize this capability of AI in the real API tracking. And we can extend this to multiple ways. There is sky is the limit, but you can extend it to with a multiple ways today. Okay, so now you might be thinking that, okay, this is good, but then how do I make my agent, my first agent, right? How do I make my first agent with this? So I'm going to tell you how do you make your own agent? First and foremost, as I explained, you can create a project in Azure AI Studio, okay, or now it is called AI Foundry, right? Then once your project is done, then you can set up the framework, okay. And as I showed you that I created an agent, and there I have defined, use a predefined structure for the agent, because in AI agent, AI Foundry agents, it is very much predefined. You don't have to worry. Tools are there, actions are there, everything is there. Just start using it, right, with your own logic. And there we have defined the tool. So this whole process of AI agent, especially in the AI Foundry, it does all the work on its own. It find out the memory, how do we share the memory internally. It uses your tool which you have defined earlier, and then it also does the resource management in its own. So you don't have to worry. It is just you have to use it. After that, once you deploy this, it will automatically work for you. You don't have to worry about it. And then you can integrate the REST API as we did. We can use the REST API call for the external system. So with this, we understood that how it is important, and it gives you transformative benefits for AI and helps you to make a enhanced decision making and run your cloud operations in a proactive approach in a nice way. So with this, I have done my session. Floor is open for you to ask any question.